So now let's talk about inverse functions. If you have a function and on that function exists a point xy, in order for it to be considered the inverse, the point yx will have to exist for the inverse. So that means that for the original function, the domain will become the range in the inverse function and vice versa. The definition of inverse function is two functions f and g are said to be inverses if f of g of x is equal to x for every x in the domain of g, and if g of f of x is equal to x for every x in the domain of f. And I know that that can sound a little wordy, but to summarize it, we have to do what is called a composition. And when we compose the functions, we are trying to determine if it will simplify down to only x. If the compositions simplify down to only x, then that means that those two functions are inverses. So let's look at this first example. We're going to verify if the following functions are inverses. So, in order to do that, I am going to take my g function and compose it into f. So let's start with that one. If the f function says 3x squared minus 5, that means I have to take 3 times something squared and subtract 5. The something is going to be that g function. So I am substituting in my g function. And now let's simplify it. First, we have a square root and an exponent of 2, and they're inverses of each other, so they cancel out. So that means I have 3 times x plus 5 over 3 minus 5. Secondly, I'm multiplying by 3, but also dividing by 3. That's inverse, so that's going to cancel. And that's going to leave me with x plus 5 minus 5. Lastly, positive 5 and negative 5 are opposites, so I have x. So far, it is looking like the function f of x and g of x are inverses, but let's be sure by composing f into g. So if I take my function g of x, now I'm going to put f of x in the place of x. So the function g of x says take the square root of something plus 5 and then divide that by 3. The something is going to be my f of x function. So 3x squared minus 5 will go inside of that parentheses. And now we're ready to simplify. Essentially, we're going to do everything in the reverse of what we did when we composed the g function into f. So, first we're going to simplify the numerator. And when I simplify that numerator, the minus 5 and the plus 5 will cancel out. And that is going to leave me with 3x squared divided by 3, all under a square root. And then I can simplify the 3's because they cancel. And then that's going to leave me with the square root of x squared. And lastly, because I'm taking the square root of x squared and their inverses, I'm left with x. So both compositions resulted in x. So that means that yes, f of x and g of x are inverses. Now, it did say in the directions that we were verifying, so essentially we knew it. But in order to verify it, we have to show that the compositions work both directions. So let's look at the second example. Again, we have f of x and g of x. It says verify. So we're going to verify it by using compositions. Starting with my f function, I'm going to substitute my g. F says 3x plus 5. So I just like to write that with the parentheses wherever x occurs. Now I'm going to drop g of function right inside of that g of x right inside of that parentheses. Okay, so now we're ready to distribute. And when you multiply a number by its denominator, it just clears the fraction. And that's going to result in 1x minus 5 plus 5. And when we combine our like terms, the negative 5 and a positive 5 cancel out. So I have 1x left. So let's check going the opposite direction. Now, taking my g function, I'm going to drop in my f function. And my g function said 1/3 times something minus 5/3. And the something is f of x. So we're going to transfer that 3x plus 5 right in here. So we're going to distribute the 1/3 or divide by 3. And when I do that, I get x plus 5/3 minus 5/3. My fractions are opposite, so they cancel, and I have x. So again, we have verified that f of x and g of x are inverse functions. And we did that using composition. Let's look at one more example. So again, we have our f of x and g of x, and we'll start with the f function. Five times something plus 3. The something is x minus 3 over 5. So I'm multiplying a fraction with the denominator of 5 by 5. And that's just going to clear it out. Then leave me with x minus 3 plus 3. The negative 3 and positive 3 cancel, and I have x. Now let's find the other composition. Taking my g function, we're going to pop in f of x. So g says we have our fraction. In the numerator of the fraction, we have something. We're going to subtract 3 and lastly divide it by 5. And we're going to take this f function and put it right here. When we do that, we get 5x plus 3. Now the first thing we're going to do is simplify our numerator, which means that the positive 3 and negative 3 will cancel. And then I have 5x divided by 5 which will equal x. So again, we have verified that f of x and g of x are indeed inverses.